thank you so much for having me, and Jared and Megan both for kind of conceiving of this idea to do this series this winter. And I'm just honored to share some information about some topics that are really near and dear to my heart. So, and also thank you all for being here and spending part of your Sunday with us. And I really hope that you can, or that you leave this evening's presentation with some new information, and that you are glad that you spent this time here. And so I'm going to share my screen and then get into the presentation. And as Jared said, please feel free to ask questions as we go, and I'm going to keep my eye on them, but they also have the go ahead to interrupt me, because I think that sometimes questions in the context of the presentation, can help with the flow of the presentation. And if we had the opportunity to be in a room together, we'd all be like maybe sitting in a circle, maybe having some warm tea that we're sharing. And, in the ideal world, I'd love to hear a little bit about why you all chose to come to this presentation, and if there was anything specific you were hoping to get out of it. So if we have time at the end, do please feel free to share that. And or let me see, I'm just going to minimize this, and or we can talk about it in the middle of the presentation. So Jared and Megan, I am limiting my ability to see you now so that everyone can see my full presentation. So I'll just kind of look for you to interrupt me if you need to. And I'm going to move this. Let's see where to put all this stuff. Okay, so my name is Karen Ganey, and I have been a student of permaculture for probably almost 20 years. It was a framework that I learned about in my college days when I was learning about the impact that industrial agriculture had on climate change. And it was proposed to me as a framework that could solve a lot of different problems in such a way that uses whole systems thinking and integrated and kind of cooperative, collaborative models of learning and doing. So I went on to get my permaculture design certificate and also get a certification to be a teacher in the principles of permaculture. And if you want to learn more about that subject, you can check out that YouTube video that Jared mentioned in the last presentation. I gave more of a broad overview of what permaculture is and how the methodologies can be applied. This presentation is specifically more about ecosystems and how different things like soil and water management can increase our ability to adapt to climate change. So along with starting my business called Permaculture Solutions, I do designs and installations for a number of private landowners, schools, and municipalities. I also run a nonprofit. It's actually a teen-run nonprofit that I'm the facilitator of called Change the World Kids. And we focus on basically local and global solutions for environmental justice and social justice. So that's a little bit about me and who I am. And then this is what, just a brief intro and overview of what we're going to go over. Again, I already shared, and I'm also a grower. I tend to grow a lot of annual vegetables and also perennial herbs. And I also believe in kind of applying this knowledge and using our privilege to make change better in the world. So I like to share this picture of me on the right, which is outside of the Bank of America when the Standing Rock situation was happening out west. And we were asked to do some solidarity actions with some people that invest in those, the infrastructure of fossil fuels. So I bring that up because I believe that I just want to show that I actually practice some of these principles, and it moves beyond just soil health and the environment, but we have to actively advocate for applying soil health principles in all levels of society, from our own practices that we use in our backyard all the way up, to create legislation to protect our valuable resources. So this presentation is going to go over a little bit about climate changes and what we are expected to see kind of in this region, given what we know and different climate modeling, some of the projections and effects that we'll have that'll happen on our landscape. Why biodiversity is something that we should be advocating for and planting for as a not only just a solution to mitigate climate change, but to enhance ecosystem functions and species diversity locally and globally. We're going to talk a little bit about soil structure, composition, how to build healthy soil, and how that relates to carbon, and how carbon drawdown and carbon sequestration is one of the many solutions to climate change. And we'll talk a little bit about the soil food web and the soil sponge, and what we can do kind of in our own gardens and communities by way of like how we plan for biodiversity and soil health. So that's what we're going to be going over. So I hope that's what you came here for today. So this is just kind of, I pulled from a climate report that UVM put out. And basically here's a little bit about what the projections are saying in light of climate change in this region. We know it's going to get a little bit wetter, and we're going to get more rain events where we get more rain coming in shorter time frames. So like we saw this actually last spring where it was like really, really wet for long periods of time going into a longer growing season that was drier. So this means that as we can adapt to these things, as we know these things, we can then therefore adapt by way of creating water catchment, water storage, with pretty simple technologies, both using earthworks, but also adapting our homes to be able to utilize and recycle water in more efficient ways. And so we also are expecting a little bit of an increase in temperature. Somewhere they are expecting up to 3 degrees in the next, over the course of the next 20 to 50 year horizon, and which will also increase our growing season, the length of it, which could potentially be even a positive. Although they are saying that with some of these changes, the growing conditions might be challenged, which could increase chances of more pests and insects, erosion, and other things. So oftentimes you might hear people say, "Oh, well, it's going to make a warmer climate here. Won't that be so great?" Because we'll have a longer growing season. It doesn't always equate to positives because there are other unpredictable factors, and they're pretty complex cycles that we're just going to be barely scratching the surface of to understand how some of these things are interrelated. So we are going to get some temperatures that are a little more mild, less extreme, and less extreme cold temperatures, which could lead to a number of different factors. We know that, like, for instance, tick populations really, in order to limit those, we really need those cold temps to kind of kill them off. But so anyway, that's some of what we see. We all know that there's contributors to climate change. Humans have had a great impact by the burning of our fossil fuels, the industrialization of our societies. And given that, we also know that the agricultural sector basically contributes about 14% of greenhouse gas emissions to climate change. And there's a lot that we can do within this specific sector to mitigate that. And I just bring that up because that's really going to be the focus. There's a lot of different solutions to climate change, and there's a lot of resources out there for every sector to be able to pivot for a more kind of livable future. And a lot of that is articulated actually in Drawdown, this book that was published in drawdown.org, and there's a lot of information online. So I encourage you to check that out. But today's presentation is specifically on growing systems and soil and agriculture. So these are kind of specific to the area of, in Vermont. I realize I just saw the poll, there's a lot of people from New Hampshire and other places around the world. I live in Vermont, so I tend to kind of focus a lot of my research on what is specifically going to be happening in this region. And I kind of already hit on these a little bit, but we're looking at increased precipitation, increased temps, a longer kind of summer growing season. And, this is going to impact different industries and sectors in varying ways. One is that we might lose a little bit of our maple sap production in the area. And there's also such a thing as trees migration, like birches and other kind of late succession forest species are also migrating north, we're finding. So that's interesting. So in general, there's a number of different effects of climate change, which is obviously just there's going to be more greenhouse gas in the atmosphere. This can lead to a loss of biodiversity because, as we know, the oceans are becoming acidified. There's going to be more water events, in shorter periods of time. This could lead to a number of different factors, as we've seen kind of in this region post Irene. There's a lot of infrastructure that was impacted. Obviously you can imagine if I had a big Venn diagram, I'd be like, drawing connections between how these things are related and why it's important to note the different changes that are going to be happening. So just some basic facts that are just good to know really about climate change. So some of the solutions, I'm going to start talking about that. Basically, we want to be increasing biodiversity. And the simplest way to put this is that plants are the least expensive way to recycle nutrients and not just nutrients, but like carbon cycles, oxygen cycles, through respiration, all the different water evaporation. So plants really do this best. And so if we can have a focus and a goal towards increasing biodiversity in our home landscapes, in our neighborhoods, in our public lands, this can impact basically nature's ability to be more resilient and adaptive to the changes that may come, and also be able to recycle and return carbon from the atmosphere and into the soil. And while I recognize that carbon isn't necessarily the only greenhouse gas, it is a contributing factor. And what we know is that life loves carbon. It's basically the building block of life. And I'm going to talk a little bit more about that. But by planting and for biodiversity, we're basically increasing the nature's ability to kind of recycle carbon. And I love this quote. So like, where do we find inspiration in some of these topics? Like, I didn't come into this world thinking, oh, I'm going to become a soil scientist, of which I'm not yet, but it's a topic that I've taken interest in and because of the solutions that it provides. But I also, look to those that have come before us. And I love this quote from Mahatma Gandhi, to forget how to dig the earth and tend the soil is to forget ourselves. And this really just brings us back to our deep and inherent connection with the land, with our food, and with each other. And I think that if we can have the lens where we recognize that we are in deep connection with these things, the earth cycles and each other, that we can be kind of well poised to both create and legislate for positive solutions. And especially during this time of the coronavirus, I think we're seeing really deeply how connected we are as a species, and how we really need to work together towards building these solutions. And so I just love thinking of that, and basically a lot of philosophers, and also like Vandana Shiva is another hero of mine who's been advocating for soil health and farmer rights for a long time. Just consistently reminds us of our deep and inherent connection to the soil, which some say actually really relates to our ability to be able to enact democracy. This might seem like a far stretch, but if we are eating foods that come from nutrient-poor soils, we might not be having the abilities and the consciousness to kind of be able to create the solutions that we need to evolve into the future, where everyone has access to clean water and clean food. So I do believe we're deeply connected to these, and whether it's correlation or causation, we've certainly seen a degradation of soils over the past 100 years, and we're kind of, our task for this time is to rebuild some of these soils. And there's a great movie out there that just came out with Woody Harrelson. Now I'm totally spacing on the name of it. Someone must know. It's a new movie that came out, and he basically talks a lot about how this is the task that we're up to. And it also shares that we have about 60 years of topsoil left if we maintain the practices that industrial agriculture is applying to grow the bulk of our food that provides for most people in this country and world. Then we only have about 60 harvests left. But there is a lot of hope, and a lot of that hope lies in these ecosystem functions. And basically, like I said before, plants provide the cheapest and most efficient way of like recycling minerals, nutrients, water, and all kinds of elements throughout our atmosphere. And they connect us from the earth to the atmosphere as well. So these are just a list of some ecosystem functions that I'm going to go into kind of briefly for this presentation. And I apologize, I realize there's probably a lot of overlap because I did cover this in my last presentation. The next one, we're going to be kind of going into some of these in more specific ways and talking about the specific plants and how to actually plant them in ways that work together. So this is just an intro again, but these are some of the ecosystem functions that are provided by plants. And so if we know these things, that means that we can design to maximize the beneficial relationships that are occurring between and among different plants. And that also kind of connect the soil microorganisms and the soil life. So we're kind of thinking of both above and below. So here, I just want to talk a little bit about like what soil is. I think oftentimes, and soil is actually making a great comeback, if you ask me, and like the circles that I fluctuate in, because we're seeing more just like bumper stickers out there, like don't treat your soil like dirt, and soil, the stuff that life is made of. And it's really true. Soil is actually the foundational building blocks of all of life. Without healthy living soils, we would not be able to survive. And I also like to kind of emphasize that soil is very much alive. In an upcoming slide here, I have just all the different, like the pounds, the literal weight of microorganisms and life that makes up the composition of the soils. So it's very much a living entity that is always kind of recycling and decomposing nutrients at a very efficient rate, providing incredible amounts of organic matter and nutrients to our gardens and landscapes. The basic fundamental building blocks are sand, silt, and clay, and the different composition of these things impacts a number of different factors in your soil, like depending on the ratios of those four ingredients, basically. And this, if you have very much clay soils, then as you all know, that soil is very good at retaining water. And sandy soils on the opposite side of the spectrum are obviously soils that allow water to kind of percolate and run through and reach the subsurface layers of the earth and the crust. So it's very much living. There's a lot that's happening. There's also a lot of space in soil, and that comes from different earthworms and arthropods and nematodes that are kind of moving around, eating a lot of the organic matter and the exudates. So what happens when we plant plants in the ground, those roots are basically experts at kind of transferring nutrients and also fluids, water, into the soil, and all of that action that the plant roots are doing, they're basically sloughing off what's called root exudates, and those feed the bacteria and fungi in the soils. And so we're going to get into that a little bit more. And so they're basically soil is that medium which produces all life, and I'm sure there's a plenty of things also that I didn't think of that are on this list that soils also provide. And so here's like another slide that just explains what exactly is in the soils. And these are kind of incredible numbers that I'm always blown away by. So if we were to take the top 7 inches of a healthy, fertile soil, this could be like a wild meadow or wild grassland, some soil that has not been tilled year after year or has a lot of inputs in the way of fertilizers or pesticides. So this is basically pounds per acre. There's 1,000 pounds per acre of bacteria in the top 7 inches of soil. Actinomycetes, molds, algae, protozoa, nematodes, insects, worms, and plant roots. So you can now you can kind of start to really get that picture of this is a really living entity that has a lot of different activities and actions that are going on. And every one of those actions is both taking in different components and expelling certain components. So an example of that is a lot of the bacteria that feed on the root exudates. Those are also producing sugars and glomalin or glues that provide the basically the matrix that helps kind of the different soil aggregates stick together. And that is the beginning of what is the building of what's called the soil sponge. And I love that term. And because basically what that means, it helps us kind of put this visualization that the soil is actually absorbing and retaining some amount of like moisture mineral content. And it's through all of these actions have to be taking place in the soil food web in order for that that medium, that's rich soil life to actually be to sustain life and to grow nutritious foods and healthy plants. And so here's just a little bit of an image to kind of give us a sense of what those things are. And they're all different sizes. But the other thing that we're going to talk a little bit about in this presentation is basically soil organic matter. And this is the result of the decomposition of minerals and nutrients that all these little critters are producing. And as we know, just from the basics of like worms, we know that worms will kind of eat leaf litter and all kinds of different decomposing like minerals, and then they'll kind of poop out these worm castings, which are incredibly nutritious, really beneficial compounds for our soil to be healthy. And there's a number of different ways to build organic matter. And I'm going to share some of those methodologies with you so that we can all be applying these really basic, somewhat common sense practices in our gardening practices. So basically, all of these things need to be functioning and intact with each other to be, building this healthy food web, soil food web, in order, that just impacts all of life. So what builds soils? And this actually, I love this term. It's called Petrogenesis. That's the term that is like very specific to the process of soil building. And so there's a number of different things that we can apply on both a small and a large scale to really build up that healthy organic matter and get all those symbiotic relationships working together amongst the different plants. And so one of the things that we know and that we're hoping that some of this information can actually really be applied on a more industrial scale, but by not tilling the soil. Every year when a plow goes over a meadow or a crop of acreage, and it's turning those soils, what that's doing is it's really exposing all that soil life that's in that healthy soil food web to heat and air. And sometimes that actually ends up destroying a lot of that soil life. On the top, it can go up to 2 feet of soil, if not more, can be destroyed. And not only that, what also happens is when these plows are turning the soil over, there is basically what's called a plow grade, and it's where that edge of the plow comes up and continues, goes over the same place, compacting that soil underneath the part that's being tilled. And that can create such a level of compaction that it means that some water and nutrients aren't actually percolating the entire soil, and it can ultimately again lead to like lack of nutrients, lack of water filtration, in the destroying of soil organic matter, because there's no life to actually keep that soil alive. And Elaine Ingham is another incredible, she's a soil scientist out of Oregon. And what she says, in healthy living soils, their water should be able to reach a depth of 16 miles below the soil surface. And again, this would be demonstrated in like healthy meadow grasses, which are some of the most diverse ecosystems and create some of the most rich humus, which is another term we'll talk a little bit about. But when there's a lot of living organic matter, that basically creates a humus that becomes this sponge, which is like basically like a long time nutrient plan for some of these plants that the soil can continue to recycle and build upon. So we also want to do cover cropping, and this can be done in a small garden or a large garden or an industrial farm. And like we know, this is being applied, for instance, just in Vermont, we have a grower in there called Pete's Greens. They have 100 acres that they're dedicated to growing their greens and 200 acres that they keep in a cover crop rotation. So it really kind of, it means that we're applying a different way of thinking to our growing and our landscapes, because we need to think beyond our garden as just the only growing area. So this whole company recognizing that they get so many more increased yields and a healthier crop if they're able to kind of keep those cover crops rotating, as opposed to just keeping this, putting inputs as far as synthetic fertilizers and pesticides into one area and then not applying compost and other things. And so, yeah, there's all kinds of information, and we'll go into this more in the next session about which cover crops to use for which specific purposes. But oftentimes, I think what's best is to also think in terms of diversity. And there's like grains, oats, legumes, which are nitrogen fixing, and peas. There's all kinds of different mixes, rye, and these all kind of provide different things, through their plant exudates. But also they encourage different soil life to be present. So another way to build soil is through companion planting. And this is basically just like grouping plants together that work well and provide different functions. So there's another slide coming up that it gives you a little bit of an image of this. But an example would also be planting like thyme, for instance, around as a ground cover around other plants that might be more have specific root systems that are not as fibrous, but more kind of a what's it called, a taproot. And basically, so those taproots that I'll talk about, you'll see images of those and have a little list of what some of those are. But those are kind of reaching some of the subsurface layers and pulling the water and the nutrients up to the surface. So anyway, planting things that have different root structures, different purposes, and different ecosystem functions together. And that while there are very specific and scientific charts on what can plant where, for instance, marigolds and tomatoes are kind of a classic annual garden companion planting technique to bring good kind of predator insects to eat, for instance, tomato hornworms. There are also there's general guidelines as well. Like you can get very specific, but also I always just recommend for people to not get too bogged down when you're transitioning, for instance, your garden to be a no-till garden where you might choose to start integrating perennials and annuals. Oftentimes I'll plant things together because I think they look nice together, or because one is clumping and one is spreading. And I see the benefits of those working together, over and over and over again. And I really encourage us all to kind of be the experimenters, the scientists of our own world and our own gardens, and make those observations. And you'll know if things are working well together because every plant, has enough water that it needs. It's producing, it's going, really well from the flowering to the fruiting stage. There's plenty of flowerings. There's good green leaf matter. There's all kinds of indicators to sort out if your plants are getting what they need. So basically, it's because of this carbon matrix that forms when all these practices are implemented, and that actually are able to retain water and nutrients within the soil. And this is basically called the soil sponge. And I'm going to attempt, I might have to stop screen sharing for a moment, but I'm just going to show us a quick little video that articulates this topic that I am talking about. Just a second. And that is here. Thank you for your patience with this. So who I'm going to introduce you to right now, his name is Walter Ganey, and he's an Australian soil scientist. And he is going to give us a little bit of an explanation about basically what is called a soil carbon sponge. And he is an incredible resource, has a lot of YouTube information out there, and is someone who I've learned a lot about this stuff from it. But he's kind of next level. I'm giving you just like the intro. Let's scratch the surface and understand what we're talking about here.
Doesn't cost a thing.
All right, so he's talking about the soil carbon sponge as a solution to climate change.
Mineral particles, okay, and basically these are sort of glued together and held apart by these organic matter matrices, Okay, and this only has to be 3%. But because you've got those, you can actually end up with massive voids, capillary water voids, right? And so it's here where water infiltrates. It's here where roots proliferate down. Instead of being stuck with 20 centimeter soil or root growth at the surface or less, hey, these are natural soils, your prairie soils going down 5 meters. So the volume of soil resource that you are empowering and creating through the sponge is enormous. So basically the sponge is just adding nothing, right? This is nothing, this is voids. Okay, but it's basically the fungi that really are the things that, in a sense, one, create this organic matter or the carbon from organic matter, but they also glue these soil particles together as, in a sense, builders and build this sort of loose matrix of three-dimensional soil, right? And also what happens, this is really critical in terms of the biofertility of soil. Okay, 90%, up to 90% of the biofertility of soil has got nothing to do with moron agriculture and how much you add to it. It's all got to do with the surface area of exposure, because here's where your calcium, your magnesium, your zinc, all those essential cations and micronutrients are basically on that stardust, on that mineral particles. And now they're exposed, available to roots and fungi for uptake as biofertility. Before, they were unavailable, locked up, inaccessible. Okay, so the sponge very quickly gives you water, it gives you nutrients, it gives you rootability, it gives you microbial ecology. There's 10 times more life, biomass weight below our feet than there is above it. Okay? And it gives you then the productivity and the resilience. And yeah, this is the sponge.
Okay, so that's a little intro into the sponge. And I love it. A lot of his talks are very much focused on he talks about these like cathedrals in the soil, but what he was saying is that space between the soil aggregates is also what allows the roots to penetrate. And it's in that zone of the root zone where most of the activity is, and where more percentage of the bacteria and fungus is, that's all helping to recycle all those minerals and nutrients. And that process is necessary for those nutrients to become bioavailable to the plants. So really, we need healthy root zones and healthy soils, even for the plants to be able to uptake the nutrients. So I know you can share my screen. I'm just going to look through my notes to make sure I'm getting all the points in. Yeah, okay. Okay, so that was Walter Yene. And just in case it wasn't really obvious, these are also things that when we apply these practices and really focus on building the healthy soil sponge, we can actually create more adaptability in our soils and in our plants to withstand different changes. So as a grower, someone myself that likes to grow annual vegetables and perennial herbs, I've actually become more focused on the health of my soil versus the health of my plants, because there's a shift that starts to take place. And then I start thinking about, okay, how do I get that good compost that I can add to the soil composition to grow my plants, as opposed to why is the plant unhealthy? Like focusing, you can see there's a little shift there, which I just think is interesting and great. So these, I'm sharing some soil health principles, and I have some resources at the end of the slide, but a lot of these came from two people, Dee Dee Pershouse, who you're also going to meet. She has a great little video that she's created to understand the soil sponge and basically organic matter and how it relates to these things. But then also Kat Buxton, both are mentors of mine that I've learned a lot from, and who both inspired me to kind of do more presentations like this. So through the Vermont Healthy Soils Coalition and a number of different collaborative organizations, this is a simple list that's been generated to give us a sense of like, okay, what are some of the things that we can do to really build healthy soils? So we want to maximize diversity, root depth, and living roots for as long as possible. And so what are the plants that have the roots that like really survive the longest possible? these are perennials. So integrating perennials into our landscape really becomes an important step to kind of having these healthy ecosystems as growing landscapes. And I can just this basically the picture to the right kind of is an example of kind of a mixed perennial landscape where there's a couple of different trees that are flowering and fruit producing mixed in with herbs. And I think sometimes, given the way that the standard American diet has evolved, we actually forget that there's a tremendous number of species in plants and herbs that we can grow for culinary, medicinal, and edible purposes. Like the Cornelian cherry is a really amazing kind of heritage heirloom cherry that produces a nutrient dense berry, but because it hasn't it's not that easy to commercialize and or grow and ship. It's like kind of gotten out of our diet. So when I'm talking about maximizing diversity here, I'm saying yes, like in terms of plants and soil health, but also in terms of like our diets, and the more that diversified our diets can be, the more energy we might have to implement some of these practices. So we're always thinking in whole systems and how it can be applied in both small and large scale. So minimizing disturbance. Basically, it's very clear what we know is like I was saying with the tilling of the in gardens and industrial landscapes. There's a lot of soil life loss when things are disturbed. So if we can minimize the amount that we're compacting by way of driving on soils and turning them, that'll also increase our soil health. Decreasing compaction, keeping soils covered. This is another, so when we get light and air and wind hitting soils, there's just a certain amount of loss in both the material that can get blown away, but also the soil life we want that soil life to be going right up to the top of the soil. That happens really well when we're doing things like mulching. And when you mulch, you can often pull that straw or those wood chips or that leaf litter away and see that right under that is a really kind of diverse matrix of all those interactions occurring. Also, animal contact with the soil. Regenerative grazing is another topic. I'm not going to go into great detail for the purposes of this presentation, but when it comes to actually bringing carbon out of the atmosphere and into the soil, one of the really important factors is actually to get large ruminants grazing on land again. They are some of the best managers of meadow landscapes in such a way that they're adding fertility by way of manure dropping. But when perennial grasses are eaten and cut down, what happens is a large percentage of their root material will actually slough off into the soil, which adds more organic matter for the bacteria and the fungi to be eating, which then produces those glues and glomulins, which becomes this network, a matrix that is feeding all the life in the soil. And so basically that's part of the carbon cycle. And then we also want to think about water. The kind of more regenerative practices applied to water involve slowing it, sinking it, and spreading it. And so the way that this is applied on different landscapes, for instance, if you have a sloped landscape, there's swale technologies where you can dig like a culvert kind of along contour. And what that does is as the water starts to flow and comes down, it actually kind of sinks into these culverts. It slows it throughout that contour and then spreads it. It's just a great example of thinking of, how to really kind of work with and capture water, as opposed to if we get more rain events and they hit a steep slope, we know that erosion can then occur. And that leads to property loss, value decrease, et cetera, et cetera. And so another really important factor in order to maintain water is to have that good organic matter in healthy amounts in the soil. And what I've learned from Walter Yene is up to 1 gram of carbon. I actually have it in here. I don't want to mess up the quote or the fact, but that basically increases the amount of water that can be stored in the soil. So if there's not carbon-rich soils, there's less water that's getting stored. And if there's more carbon in the soils, that water is getting stored for longer periods of time, which enable the roots of the plants to be able to take up more water and nutrient over long periods of time, which then, of course, decrease the impact of the erosion and just soil loss. Okay, so here's just some facts about carbon. There's just like a kind of a simple, there's all kinds of stuff online, and I just like to pull things that are kind of colorful and effective as far as really showing how these systems are integrated and interrelated. And so basically carbon farming is a little bit what I shared about decreasing tillage, increasing large ruminants on land, so that you can create rotational grazing patterns where the carbon is basically getting taken right out of the atmosphere and put into the soils. And here is another YouTube that I wanted to watch that just explains a little bit more about this image and how these things are relating. So I might have to do this again and go back here.
Just like clay. Surfaces depends on the type of clay as well, because they have different reactivity and different
here she's talking about clay as a way to retain water.
We've also got this inherent capacity that we can see, but ultimately what it's about within a soil type is managing the supply of organic matter and the loss of organic matter. So if we think about this in terms of the soil profile and the flux and flow of carbon around the landscape, now we have the carbon loss via soil erosion. So we've got that red arrow there, the top right-hand side. So if we just, that's a given. We don't know necessarily that that returns to the atmosphere under all conditions, but it's certainly a loss from the particular site. We've got carbon being sequestered in the soil through photosynthesis. So we've got this influx of carbon dioxide through the process of photosynthesis into the soil. Once it's within the plant, it goes from the gas to a liquid in a plant and then into, I guess, a solid in terms of roots. So carbon gets into the soil through root exudates, root sloughing, and litter from above ground, and as well as dung as well. So we've got this above ground contributions, below ground contributions. Once it's in that organic matter pool and cycling around here, we have organic carbon that can be protected within aggregates. So it's basically protected from soil organisms and it's not readily accessible for decomposition. It can be chemically protected, so that's where we get these mineral associations and organic carbon being bonded with clays. And then we have this accumulation of microbes. So dead microbes is a way of sequestering carbon, but live microbes also respire carbon. So this is where we get this soil respiration, and we also have plants respiring as well. So ultimately, we just want the photosynthesis carbon sequestration to be greater than the loss by soil and plant respiration.
Okay, so hopefully that just helped explain a little bit about what's going on there. Oops, how do I do that? We'll go back here. Am I still sharing the screen? I think I have to go back to screen share. Okay. Any questions before I move on? Okay. I'm just going to keep rolling then. So applying compost is another way to kind of increase soil health and ensure that the soil is really rich and full of all those beneficial microorganisms, arthropods, nematodes, and that entire array of the soil food web. And so if your soil is not exhibiting good soil sponge characteristics, meaning that you have to water like every day, like usually healthy soil sponge will actually be able to provide the amount of water that is needed for the plants that are there. And really, if we're able to maximize these methodologies for the benefit of the soil food web, we actually end up having to water a lot less in our gardens. And I have seen this time and time again. Even last summer, we actually, as you probably remember, experienced quite a bit of a drought. in gardens that I had been consistently applying mulch and compost to, I was able to push my hands kind of and open up that soil and look under and stick my finger in, and literally within like the first half, like first couple inches of that soil depth, I can sense and feel moisture. So it really, really is incredible what these microorganisms are doing. And so if someone was to come to me and say, hey, you know, my plants are small, like my soil's not great, the water runs off, the first step that I would say is to apply compost, and apply compost that you know is rich in soil life. And oftentimes we can do this by inoculating our own compost piles with sometimes even just a tablespoon of soil from like a forest, which has thousands of microbes in it, and bacteria and fungi, or by way of like purchasing compost or purchasing inoculants that will help get that process going. And so basically this is just really clear, like there's certain practices that where soil will carbon will leave the soil, and then there's practices where carbon will go into the soil, and that's really what we're trying to maximize here. Okay, so we've been talking about the soil carbon sponge, and if this was a new term to you at the beginning of the presentation, hopefully by now you know a little bit about what we're talking about and have some sense of what you can do to really build that healthy carbon sponge. So the image here on the right is that like just by raising organic matter by 1%, and this could be done by applying like a leaf litter mulch to your garden, any kind of mulching techniques, having that really good compost in there. But those practices can lead to the retention of an extra 20,000 gallons of water per acre. Now, that to me is an astronomical number. And, you know, we're living in these times where if we're looking at increased drought occurrences into the future, I would bet that anyone that is trying to produce a crop for yield and or food is now really paying attention to that organic matter content. If we know that we can save up to 20,000 gallons of water per acre, that's not a small number, and that's not small conservation at all. And so, so how do we do this? We want to really kind of build towards that rich humus, and also, have plants that are working together. So we're not monocropping, but we're really diversifying what we're planting together. And let's see, there is another video here. I hope this isn't too much to kind of go back and forth, and that these are all tools to just kind of help explain these different systems and how they work together. And so let me just grab this here. Never mind. Oops. That's another one by Walter Yene. So I'm going to skip that one because we already saw him, and he's basically just explaining the same thing with the creation of the soil sponge. Okay, so let's get back to our share. And here we go. And now back to the presentation. So another thing that we want to do is really select plants. And, as I've been talking, I can, I hope you're all thinking about this is a perfect time to be planning our gardens for next year and ordering seeds and doing designs. And it's all very exciting. And I'm trying to kind of bring in some photographs to the presentation. So to kind of inspire us with some color from the summertime during this time of year. But another factor that we really want to consider, and I hope you're all thinking about now doing, is integrating more, perennial shrubs and trees into your growing landscapes. And so when you're in that process, I want to encourage more native varieties of perennials and shrubs. And it's these native varieties that are not only kind of used to the native soils that we have here in this region, but are also the best for native pollinators, bees, and insects. And this is an important time to be thinking about the insect world. We are living at a time of extreme species lost. Every day, up to 200 species, and a lot of this extinction is impacting the little critters and insects among us. And so there's a number of different techniques that we want to plan for and design for to keep habitat thriving for these little buggers. And so natives is one important thing. So I encourage you to go to local nurseries. And this does not include Walmart and Home Depot, where neonicotinoids are being used. We know that these neonicotinoids disrupt the evolutionary process for bees and other pollinators and are extremely detrimental and are factors in colony collapse syndrome that we're seeing with our honeybee and pollinators populations. And so go to the nursery, always make sure they're not using any sprays or neonicotinoids, and and ask them specific about if they're selling natives. And there's a lot of times you can plant really diverse and integrated landscapes for pretty affordable by getting bare root stock from native plant nurseries and growing those out yourself. And just making sure that when you're planting, you're not spraying or encouraging, the input of any synthetic fertilizers. Really, if our soils are healthy, our plants will respond well. And so select plants that provide different ecosystem functions. I'm just going to go over some of those functions coming up here shortly, so you know what I'm talking about as far as soil building qualities. Also, mulching is another thing that can really help. And another technique for gardens that I implement, and I really encourage others to do as well, is to really leave those woody stalks and stems of perennials through the fall and winter and actually into the spring. And this can be hard to do. I think that we are, at least in the landscaping industry, we're coming out of a time where people have somehow kind of developed this idea that things should be really clean and tidy and short. And this is actually not really good for soil health or ecosystem functions whatsoever. We need to be leaving the stalks of woody perennials and herbs, because what happens is, as that plant goes dormant, as the cold weather as the cold weather comes, those plants take up a habitat in the stalks and stems of a lot of those perennials, and will actually live and go dormant and then kind of emerge in the spring. And if we just cut everything down to the ground, we're not actually encouraging those insects. And then even yesterday, as I was putting together this presentation, I was looking out over where I am, and there's this garden, and I could see there was actually 3 different species of birds that would come in different flocks onto the herbs that were planted here. The stalks are all still standing, and I can see what they're doing is they're actually eating the seeds. So in the first, oftentimes in the springtime, in a lot of my herb gardens and perennials, I will always let that first flower go to the insects for pollinators, so they can get that nectar in the early springtime. And then similarly in the fall, I will always let them go to seed, so that those seeds end up providing really important nutrients for birds throughout the winter time. So that's just another technique that I really recommend to maximize this biodiversity. And we can really see those benefits then again, throughout the garden year after year. If you start applying these practices, you'll start to really see the way that the different insects, birds, and soil life is benefited. And it's quite miraculous. And then the other thing is, in the springtime, we want to wait until there's at least 2 weeks of temperatures above 50 degrees Fahrenheit, because what that does is that gives time for those insects to kind of emerge from those stalks. If we interrupt those life cycles, and I get it, like I'm when springtime hits and we have spring fever and it's a nice weekend day, you want to go out into the garden and start cleaning things up and raking that leaf litter. But really, we need to discipline ourselves to leave it 2 weeks above 50, so that we give chances for those insects to emerge. And, and then this is really just kind of the meta narrative of these practices, I really believe are actually bringing us better in touch with nature's cycles and nature's rhythms, and also helping for our own kind of, reconnection with these elements. And because we're being guided by principles of life rather than, unknowns or impulses that, lead to species loss. Okay. So always covering the soil. So this is one of those soil health principles, and we really want to make sure that all areas are always covered. And again, we can do this in our annual garden by way of cover cropping and mulching, but we can also do it with plants. And one of the best things that I think nature has taught us is when there's a disturbed area, there's always a plant community that comes in and occupies that area. Those plants are actually really important, and they're providing extremely important nutrient recycling functions by way of like those plant root exudates that are bringing those nutrients and that water to the soil to then build the organic matter for the next succession of plants. So whenever we forget like what we should be doing or what the best practice is, we can always really look to nature to guide us in that way. And one of the things that you might hear a lot when it comes to permaculture is um, gardening, forest gardening. And I always tell people this, sometimes it does mean kind of gardening in the forest, but more than not, mostly means gardening like a forest. And again, like, I'm sorry if you're in my last presentation, I am covering some of these topics again, because I just feel that they're really so important for us to get and understand and implement. And so in a forest, there's no waste. Everything is utilized, from, in every square inch of space. And so we can actually recreate those systems by being inspired by that design. And so, there's all kinds of things that we can plant as ground covers and to really make sure that none of that soil is bare. And if we're talking about annual growing systems, the best methodology there would be to really use mulch with like leaf litter. Straw, I know, is getting increasingly expensive. But if you have to, you can use cardboard, just to keep soil covered so that it's not, we're not losing all that benefit of like the process that the root exudates are kind of sloughing into the soil and giving that biology to really do its thing and break down and build more organic matter. And so these are just a list of I always like to give people some ideas of what to look for when they're going to the nursery. And on the left here is just some of my favorites for both their ability to kind of cover ground and for their structure and their perennial ability to kind of come back year after year. And I think that's the other thing about the beauty of nature. There's natural abundance in these systems. So, while we're also looking to create these like beautiful plant communities, I think that can really translate into social communities. And, we use these as metaphors all the time, like in our own social networks. We want, of course, diversity of perspectives and, people that bring different strengths and weaknesses. And it's the exact same thing that we're looking at in these growing systems, because everything can work together to really create a more balanced system where the soil's carbon sponge is being built and all the benefits of that system are benefiting all the parts in that system, just like we would want to design our social systems for as well. Okay, let's see. And so I talked a little bit about this last time, but again, here are my favorite nutrient accumulators. More often than not, these are, they're also called dynamic accumulators, which I love because it is a very dynamic process. But these are generally plants that have tap roots. And if you pull up a plant that has a tap root, most likely what the purpose is it's really bringing nutrients and water up from the subsurface to the surface layers. And also by way of storing sugars, because some of those meaty roots are kind of basically incredible storehouses for carbohydrates and sugars, which also through the root, remember I said through these root zones, this is where most of the biological and fungal activity is really taking place and transferring those things. So it's great. And then on the far right, we have this fibrous root, like that oat could be any kind of perennial grass would have a similar structure. So you can start to see like how if a large ruminant grazing animal was able to come down and kind of munch that grass, 2/3 of that root matter going into the soil is going to have a really incredible impact on that soil. So let's see, I just want to take the time. Okay, great. So nitrogen fixers, as we know, often plants, they basically need, you'll often hear this like NPK ratio. Nitrogen, phosphorus, and potassium are like the three main building blocks from nutrients that plants need. So we want to basically, again, be designing for these plants to be putting that into the soil. And if nitrogen is actually naturally found within the soil's ability to store carbon increases. If we are applying synthetic nitrogen fertilizers, basically that carbon cycle is disrupted and the carbon gets then dispersed. So that's kind of a simple fact that just means like having these biological systems in place increases our ability for soil to store carbon. And if you remember from kind of the beginning of the talk, that also really increases the soil's ability to store water. So nitrogen is like no joke. We certainly need it in our soils. We need to be designing for it. And there's a lot of plants that actually literally take it out of the atmosphere and put it right into the soil. And that's done through a symbiotic process with a beneficial bacteria that lives on the roots of these systems. And you can see these little root nodules. They're like tiny little nodules and that are doing that action of nitrogen fixation. Yeah, so it's just another way. So like, and even if you have these things, in your annual garden, oftentimes you can plant. I encourage people to plant around the perimeter of their gardens or to have pollinator gardens in close proximity to where their annual gardens are, so that these actions can be taking place. Because what we know from tree forest ecosystems and actually healthy soil systems is information and nutrients and water are actually really shared across great distances and through the mycorrhizal fungal networks. So I think like having these things placed upon the landscape will really increase all the activities and actions that we want to encourage. So yeah, I kind of, here's a little garden that I did last year just to kind of say, well, how can this, just to show I'm rather like how this can be applied. And because sometimes it's a new concept and it can be hard to imagine like what that means when we're in this area. And so on the left is just a picture of an area that was prominently goldenrod. And what I did is just what's called sheet mulching. So the area under the soil all has cardboard that was just really placed right over the meadow grasses. And I did what's called a chop and drop method. And I have a hand sickle that I use, and I chop all of the tall kind of goldenrod right at the base, so it kind of falls over. And then I layer cardboard on top of that and then build kind of a compost mulch topsoil composition. And I let that sit for 4 to 6 weeks, depending on the time of year. And then I go back through and I plant plants, perennials into that. And what that does is all of that biomass that is underneath there is basically building towards soil health that will feed these plants in years to come. And we, like I said earlier, we really want to be increasing the amount of biomass in our growing systems so that we can be recycling carbon and water at kind of a faster rate to increase that biodiversity. So, so this is an example of different things, and this is a pollinator garden. So effectively what we've done here is where there used to be one species of goldenrod, we've now created over 75 different species of plants. There's not pictured here on the left is actually a layer of blueberries. There's currants. So there's different sizes, different berries, and different pollinator perennials, and some medicinals as well, because this installation, I wanted to incorporate, perennials for pollinators, but also medicinal culinaries for actually harvesting and using. And if people are interested and we have time, I have a lot of images like this on my website, and we could go through that together, or you're welcome to visit on your own too. So this is just kind of a brief review, like why is it important that we apply these methods? So like, as I just was saying, increasing biomass really helps to store carbon. And that is really the fundamental building block of all of life. If we have carbon in our soils, then we encourage soil microbiology, which increases surface area and builds that soil sponge that Walter Ganey was drawing out for us. We're connecting with nature cycles. So we're kind of like living into our full human potential. We're becoming empowered to understand the different factors to increase our local food system, and actually in such a way that is like also increasing the soil food web and the nutrients that we're able to take in from our local environment by way of food. So we're building soil. Again, soil is the building block of life. It's necessary for us to live. All species eat, and we can just design for and maximize the beneficial relationships of those species so that we can be like harvesting the benefits of that process by way of composting our own food scraps, and also by way of having good soil life in our soils. So this kind of increases our interdependence and our conscious interdependence of with each other and the systems that we're involved with, which of course leads to our ability to adapt to and respond to change. And so what else can we do? So throughout the course of the presentation, I've talked a little bit about climate change and what's coming down the pike, and some techniques to kind of build up our local ecosystems to be able to adapt. And but there's a number of different things that we can do to kind of build on these solutions. And so we can just acknowledge our community assets. Like anywhere we go, anytime that we ask ourselves these questions, I feel like we're able to access the power of our own inspiration and solutions. We don't need to continually look to outside factors to tell us what to do, but when we become empowered, we can increase our own food sovereignty and local resilience. And ask ourselves, how are we functioning along these natural cycles? Are we working with nature, or are we working against it? And if we kind of basically put anything that we're doing in our gardens, to this test, we should be able to say, oh no, I'm working with the cycles of nature here, and I can see, here's how I'm doing it, and here are the impacts. I also like to bring this question, like, how are we practicing unbiased diversity, inclusion, and equity? I think it's important that we are looking towards our social systems as well to become, equitable and diverse, so that all people can have like the land and food access that they need to thrive. And what do people already know? So I think that everyone also has a lot of inherent knowledge that you've learned over the years from your experience and observations. And so how are the ways that you can apply that knowledge and experience to your landscapes? I think that a lot of this comes down to really accessing our full human potential and applying the knowledge that we know. And so the image on the right here is just, these are the three principles and, the three ethics of permaculture and the 12 principles. And I'll just talk about the ethics just briefly, and that if we can be caring for the earth and caring for each other and making sure that everyone has a fair share, then the future generations will also have what they need to live healthy, thriving lives. So I feel like we're really living at this threshold of time where we can be making decisions that really benefit all of life. Okay, so this is my last slide, everyone. So I just wanted to share that there are a couple opportunities to take some of this information and engage deeper with it. And that there's an incredible upcoming series called, I'm going to see if I can get to, oops. Oh, well, oh, good. This is the Vermont Healthy Soils Coalition. They have put on 3 different series, of which you can access all of them on this website. And they're really, really informative, and from Indigenous land practices to kind of going a little bit deeper with some of the concepts that I've talked to you about. But this is the next one. It's coming up. It's going to start in February, and you can register. I'm pretty sure it's a sliding scale rate, and you'll be learning from the best, the creme of the crop, as we'll say, like Didi Pershouse and Walter Yene, and also some really incredible Abenaki leaders. So it starts on February 10th and goes until April 21st, and it's all virtual. So I've done the past 2 series, and I've learned so much. It's basically one of the reasons why I've kind of wanted to take it upon myself to share some of this information with wider audiences. So I can't recommend that enough. And Didi Pershouse, I've listed her here. She has a lot of resources. You can just search her, and she has a website and also YouTube channels. And if we don't have a lot of questions, what I was going to do is end with one of her videos where she gives a really simple experiment to show how to build the soil carbon sponge and what the difference is when you have organic matter versus when you don't, and like the way that water runs through the soil. So another incredible resource, Kat Buxton is a good friend of mine, and she runs Grow More, Waste Less. And she has a number of different handouts and presentations on her website as well. And she is a lead expert in kind of soil science in this region. And then Walter Ganey, I just wanted to list his name, and you can search him on YouTube because he goes into more depth about the specifics of soil science if you're really interested in that topic. And, I have sat through hours of presentations from him, and I just can't recommend it enough to really understand how some of these things are working together. So that I brought us to about 4:15, and we have 15 minutes, and I'd be happy to take questions, and or we could also have just an open discussion about methodologies and practices. I can show some images of what some of these practices look like in garden designs, and or the short video. I think it's about 5 minutes that Dee Dee Pershouse does on, understanding how water flows through different soils. Hello?
Does anyone,
Oh,
you can
let me
put
just
your questions in the chat, or you can unmute yourself probably too if you have a question for Karen.
I have a question.
Yeah, go for it. Kiss the Ground. Thank you, Jared. Sorry, I just want to say briefly that movie is called Kiss the Ground. Highly recommend it.
I have a question,
Yeah.
Karen, and it's about the new garden you were showing that you started, that you cut down the goldenrod and put the cardboard down.
Yes.
And then you you said you created topsoil and then planted on top of that. So what did you mean by you created topsoil? You dug it up from another part of your garden, or you got it a truckload brought in? What did you mean by that?
Yeah, so I basically created a composition that was topsoil and compost, and that I just got with the resources that were closest to that client, which was sheep manure and a topsoil mix. So basically I just made my own mix and applied it to the top of it. Yeah.
Okay. Thank you. And then you can just dig through that cardboard, or was there enough topsoil that you didn't actually dig through the cardboard when you were planting those things?
Yeah, that is a great question. I love talking about these methodologies because sometimes it sounds so simple, but there's some nuance. So I let it sit for about 4 weeks, and this was during the summertime. So I know that there was maximum breakdown that was happening under the soil. And then I did actually go in, and I use what's called a soil knife or a hori-hori, and it's kind of a pretty sharp gardening tool that can break up roots and weed. It's just phenomenal. I really recommend it. And I use that to cut the cardboard away, and I pull it away just from that area that I'm going to plant the plant. And then underneath that, and then I dig from there. So I put the plant, probably about 3/4 of the way in. And then I basically come back over and I put that topsoil on mulch back over the plant. So it looks like it's all one level. But what that does is the cardboard has completely allowed what's underneath that to be broken down. So it's much easier than, for instance, going into a meadow and trying to just dig a hole with all that root material. I hope that makes sense.
Yeah. And so then when you say no till, does that mean that when you're doing your vegetable gardens that you don't clear anything away? You just do the one little place where you're putting that vegetable in, or do you clear?
Yeah, no, I don't clear. I mean, I've kind of gotten used to it. It took me a bit because I was farming in kind of a conventional organic, but not conventional, so organic farming system where there was mostly naked soil. And it took me a while to kind of adapt to this method, where now what I do is I create basically permanent raised beds, and I'll use a straw or leaf mulch. But when I'm then planting seeds, I just kind of move maybe 2 inches of that mulch away. And then I plant in those little furrows underneath, in that line. And then, and it's really amazing because then I can see very clearly when I'm watering, how the germination rate is. And it really prevents weeds from growing, but those little seedlings will then come up and have access to the water that they need because there's mulch, on an inch of both sides of that seed. So it's a little bit kind of weird to do at first because you're used to just kind of planting seeds in an open seed bed that might not have that mulch, but instead you just kind of make a little furrow. You just spread that mulch, make one little furrow. And then you really don't end up needing to water it as much as you would an unmulched area.
So mulch is okay. It doesn't have to be the plants from last year that are still there.
Yeah, I could have, that's exactly right. Like, and so sometimes with the plants from the previous years, like if it's like not tomatoes, but like if it's kale or broccoli or even like herbs like parsley, I'll cut them down and take out the stalk and maybe like compost that, but then leave the roots, and then I'll just kind of plant around it. And that methodology is like, maybe a little messy for some people, but I really like to keep that root material, because that all that organic matter will then get broken down, and it'll increase the kind of nematodes, arthropods, and all the other different, like the protozoa, the bacteria, the fungi, all of that will start to decompose that old root from the previous years. But I will still clear, like I'll do selective, clearing of different roots.
Thank you.
Yeah, of course.
Karen, we have 2 questions in chat. Aaron asks, what are your top 3 native shrubs that you would recommend for gardeners for the trifecta of wildlife?
Awesome. My favorite shrubs are, one is called Viburnum trilobum. It's the high bush American cranberry. It's native to this area. It produces clusters of like bright red berries that are good for migratory birds. And it also has a very kind of aesthetic appeal, because the foliage of the leaf has some really beautiful autumn colors. Another one of my favorites is called Clethra alnifolia, or summer sweet. And this is also a native shrub, and I mostly plant this for like butterflies and hummingbirds. It's long. It takes a long time to bloom. Like in the springtime, it comes like more towards like the early part of summer. But once it blooms, it has an incredible fragrance and long bloom time. And I have seen more species of insect on this plant than I have almost any other plant. To the point where one person asked me to do a consult because she had this plant that had all these hornets on it, and she thought that it was really bad and she had to get rid of it. And I went and I took a picture, because there was more varieties and different species of pollinators that were on the plant than any other one. And you asked for 3. Okay, so that's 2. The other I would say are either like viburnum, there's a number of different species of viburnums that are a lot of them are native. But also I would say maybe the third is either Aronia melocarpa, which is chokeberry. And that is it's a native shrub that is incredible for bird habitat. So I'm always thinking in my landscape, like a couple pollinator plants like Nepeta or catmint is like a long blooming, what beautiful pollinator insectary. Anything that has like an umbelliferous flower, I'll plant intermix with like some of those 3 native shrubs. The Aronia is also it's a very nutrient dense berry that we can also eat ourselves. It's really, really tart. But it does well, and it integrates well with a lot of different soils and brings a lot of habitat. So that would be my trifecta.
The second question is from Tom. Over the winter, do you simply mulch your annual garden, or do you grow a cover crop?
I think that depends on what you're also trying to grow, Tom. So I would need to know a little bit more, but like for an annual, like I think for a large annual garden, I would recommend a cover crop, like a winter rye, or like a oats, peas, vetch mix. And oftentimes like a really good time to plant that cover crop in your annual garden would be early fall. Like you need probably 30 to 45 days, depending on the crop, to allow it time to grow. And then what'll happen is it starts to get cold, and some of those plants will die, and they'll just basically fall over and then provide a mulch for that area, which will just break down over time. And then you can go the next year, and you can either do what I was saying earlier, is kind of pull that aside to plant into, or turn it in. And that's the only time that I'd really, and it's different than tilling. You can turn in cover crop into the top 6 inches of your soil, and that's different than tilling because you're actually adding something. So those are what you could plant those. They basically winter kill, push it aside with your hands and plant into it, or turn it over. And then, but if there's other areas, like I would do that if I had a large, for my large annual garden. But I also would do a lot of mulch, like depending on what's available, what resources you have, and what's easily accessible. Like I mulch all my garlic with leaf litter that I basically rake mostly from my driveway. Leaves are incredibly valuable to add to compost systems and also to mulch because, the native soils and microorganisms are so used to breaking it down and they do such a good job. But I don't recommend taking those leaves from like forested areas. But anyhow, so those are the two things that I do. And it just depends on your growing system and what you're trying to put into the soil. Like by growing oats, peas, and vetch, you would be putting nitrogen in your soil. So I'd recommend doing that in after crops that are heavy feeders, like corn and tomatoes, for instance. I hope that helped make a little sense as well.
In terms of creating the soil sponge, does it matter what type of carbon source you use? Because, I mean, if say you use straw as compared to wood chips would be more denser. But in terms of capturing water, does that really matter? The density, the carbon?
Yes,
I mean.
I do. I think that's an excellent question. And I think that both have the ability to build that carbon sponge, the soil carbon sponge, because they're like effectively preventing the soil from like eroding and dying from sun and heat on the top of the soil. Wood chips, because it's a carbon source, the process of breakdown actually ends up, and it's a wood source. So that's the other thing to understand is like forest ecosystems are dominated by fungal systems, whereas annual growing systems are dominated by bacterial systems. So what the wood chips do, which is like the long-term effect of having a wood chip, is that it increases the fungal dominated communities. So like I will put wood chips, for instance, on my pathways, and then I'll do a mulch, like a straw or a leaf litter on my beds. And because that ultimately ends up bringing the fungal communities, and the process to break down the carbon rich wood chip also requires nitrogen. And if you end up incorporating those into your annual growing beds, it will strip nitrogen from the soil in order to break down. So there's a little bit of nuance there. I think they both provide certain functions. And like I had a couple more slides that I was going to add. One of them was a picture of a wood chips and the fungal life that, like, when I picked up this clump of wood chips, it just stuck together because of that fungal network. And so, like, some people say, don't ever put that because there's straight carbon in your soil because it'll take away the nitrogen. But I think that we're actually learning there's nuance and difference within that. And the other sources of carbon, just since you brought this up, like for instance, biochar is theoretically an incomplete combustion of wood or carbon. And basically what it does is it's just an exoskeleton of a building block. So we put that into soil and it becomes like a hotel for microorganisms and fungi and bacteria to live in. And then that increases the carbon. So that's another thing that you can do to get that soil sponge built up, is experiment with different biochars. And now we're kind of getting to the point of understanding like where the law of efficiency kind of matches with that. Like, because you can have too much carbon in your soil, and that might take away like nutrients that your plants need to be uptaking. So there's certain thresholds is what I'm trying to say. And there's a lot of information out there on like making sure that when you get biochar, that it's actually like a properly, incomplete combustion of a wood product, and making sure that wood product isn't like a plywood, but it's just like a good hardwood. So that's just one other technique I would say to increase carbon in the soils is working with biochar. Yeah, I hope that answers your question. Okay, thanks for your question. So there will be a lot of new information next time if you choose to come, and bring your questions, and I'll have a lot more pictures from like experiments in the field so you can see, again, like specific plants and their ecosystem functions and how that all works.
Great. Thanks, Karen. Thanks, everyone.
Thank you all so much.